Good morning, everybody. It's been a while since I've done one of these recordings, and my voice is a little hoarse today, so excuse that. Today we're going to talk about periodic trends and atomic size and radii. And again, we're still trying to figure out what all these electrons are doing in terms of making materials and compounds and all the things that we have in our amazing world. So the first thing we're going to take a look at is how do we determine the size of atoms, the atomic radii. Remember that atoms do not have sharp define boundaries. You've been seeing me scribble and the s, p, d, and f orbitals and trying to figure out those distances. So for a diatomic molecule example, we could have oxygen, we could have hydrogen, we could have nitrogen, and keep on going there. Use half of the distance between the atoms. So you can see here that they have the chlorine atom down here, and you need to remember that this is a region where these electrons are traveling. And so here is our nucleus, and we know that that's the center of the atom. And what they're actually doing then is taking the distance between from nucleus to figure out the radii, to figure out the size of the atom. Now, in doing this, they have been able to figure out certain trends in atomic size. So if we take a look and we're going across our periods, we know that periods go in from left to right, and you can see that if I'm on the left-hand side, look how large these are compared to the right side of the periodic chart. So we need to talk about what's going on there and why, as we are adding more protons and neutrons, protons and electrons, as we go across, why is the atomic radii actually getting smaller? So let's go to the next slide first, and then we'll come back to here. So it's called this effective nuclear charge, and we have a force of energy between the protons and electrons. And if you think about that, a proton is positive and an electron is negative. And so we have this attraction between the two pulling this in. The more protons we have, the more effective nuclear charge, or it's this nuclear force in the atom that's going to pull it together. So adding protons and electrons in the same energy level, meaning that N is equal to 1, 2, or 3, increases as F. What is the result? And the result is that you increases that force, so it is an increase So just as I talked about, it is that increase in force between the protons and electrons. It results in a smaller radii. So if we look back at this, you guys can see that N here, N is equal to 1. As I go across, I have hydrogen, which is larger than helium, which is to the right. If N equals 2 and I go across in this manner, yes, I'm adding more protons and electrons as I go across, so that effective nuclear charge increases and pulling in those electrons. So this right here, I know it's kind of small on your screen, but it says increasing the number of protons in the nucleus pulls in electrons. This is our effective nuclear charge. It's called our ZEF, and it makes the atom smaller and smaller and smaller. Now that's going to play a part when we start doing looking at how bonds are made. So we're just going to keep this really simple. Circle the larger element in terms of atomic radii. So you need to look at sodium and chlorine. They are both in the third energy level, and sodium is further to the left on the periodic chart, so that one is going to be much larger than chlorine. And if we look at this, we have 11 protons, we have 11 electrons. For chlorine, we have 17 protons and 17 electrons. This has a lot more Zeph over here, so it's going to pull it in, make it smaller, so sodium is going to be larger. If I look at strontium and iodine, it would be the same reason. I jumped to number 3, sorry. Strontium iodide would have the same reason as I just mentioned with sodium and chlorine. So strontium would have the larger radii. And then if you look at where sodium and rubidium are in your periodic chart, we are talking about going down a family. As I go down a family in this situation, then I'm going to be adding energy levels. Well, if I'm adding energy levels, keep it logical. that if I'm adding those energy levels, it is going to get larger. So the further down the family, we have larger radii. So if I look at sodium and rubidium, rubidium is further down the family. That's going to be larger in atomic radii. Between nitrogen and phosphorus, they are right next to each other, but phosphorus is in the third energy level. That one is going to be larger. Okay, so that's all with effective nuclear charge and atomic radii and how they are combined. You just really need to remember the trend that the further to the right that they are in the same energy level, the smaller the atomic radii. All right, I hope you guys have a wonderful day. Good luck on completing your homework in this section.